Let's see how do we solve homogeneous differential equation. Here's an example of a homogeneous differential equation. Let's see how do we solve this. So we have a 6-step process. Let's go through the steps. The step 1 is to simplify the differential equation, make sure it is in this form. The step 2 is to identify and verify that this is indeed a homogeneous differential equation. And step 3 is to do a substitution, which is y is equal to vx and y prime is equal to v prime x plus v. And step 4 is to separate the variables, and step 5 is to integrate, and step 6 is to simplify, resubstitute, and simplify again. So we're going to follow these steps to solve this homogeneous differential equation right there. Alright, so step 1, as I said, it's already in that form, so it's a check. And then step 2 is it's a homogeneous differential equation. You can verify. Here is my f of x comma y. So therefore, if I replace the x and y by tx and ty, then I am going to have, if I simplify this further, I am going to have the following, which is 3 times t squared y squared minus t squared x squared divided by 2 times t squared xy. If I further simplify, I am going to have t squared 3y squared minus x squared divided by t squared times 2xy. And as you see here, this t squared and t squared gets cancelled. Then I'm left with simply 3y squared minus x squared divided by 2xy, actually, which is f of x comma y. So this is equivalent to t to the 0 f of x comma y. So here we can say our alpha is equal to 0. Hence this function right here, f of x comma y, is indeed a homogeneous function. So we can say the function f of x comma y is a homogeneous function. So let's go to the step 3. What is our step 3? This is a very crucial step. It is the substitution. That we are going to substitute y is equal to vx, and y, that would imply y prime equals v prime x plus v. So if I plug this back into the differential equation, which was y prime equals 3y squared minus x squared divided by 2xy, you see that you would agree with me that this is going to be v prime x plus v equals 3 times vx the whole squared minus x squared divided by 2 times x times vx. This is going to be 3 times v squared x squared minus x squared divided by 2x squared v. And so if I simplify, if I take the x squared out, I am going to have 3v squared minus 1 divided by x squared times 2v. And again, I can cancel the x squared and x squared out. Then I'm going to be left with simply 3v squared minus 1 divided by 2v. Let's simplify this furthermore. So if I write, what do I have? On my left hand side, I have v prime x plus v. On my right hand side, I have 3v squared minus 1 divided by 2v. Alright, so let's simplify this further. If I simplify this furthermore, you agree that I can write this as simply v prime x equals 3v squared minus 1 divided by 2v minus v, which simplifies into 3v squared minus 1 divided by 2v minus 2v squared over 2v, which can be written as 3v squared minus 1 minus 2v squared divided by 2v, which is equal to v squared minus 1 divided by 2v. On my left hand side, I have v prime x. So this is our end of the step 3. So the next step is to use the variable separable, which we're going to do that. So to make my life easy, I'm going to rewrite the left hand side in the following way, which would be dv over dx times x equals v squared minus 1 divided by 2v. And now if I simplify this, you would agree with me that I'm going to have 2v over v squared minus 1 dv equals 1 over x dx. And now here I have separated the variable. Then let's go to the step 5. The step 5 is to integrate. So if I integrate both sides, then I am going to have the following, which is integral of this equals integral of that. And now we can use the substitution methods on the left hand side, and that that would give me the answer as ln of v squared minus 1 on the left hand side, and on the right hand side it's going to be ln of x. To make my life easy, to make the computation easy, I am going to add ln of c instead of just a c, and here c is an arbitrary constant. And this is our last step. The last step is to simplify, resubstitute, and simplify. So if I simplify this, you would agree with me that I can simplify this in as v squared minus 1 equals cx. Again, c here is an arbitrary constant. Now if I resubstitute, we substituted y is equal to vx, so therefore if I resubstitute, then you agree that my v would be y over x. So if I plug this information back into my solution here, then I am going to have y over x the whole squared minus 1 equals cx there. And now if I further simplify, I can simplify this as y over x the whole squared equals cx plus 1, where c is an arbitrary constant. We can further simplify, but I think I'm going to leave it right here. And here is your solution curve for the given homogeneous differential equation.